Okay, these are our notes on Unit 2, the sun, specifically talking about the energy of the sun. Our essential question for this is, why is it important that the sun uses a nuclear reaction? And by the end of class, you should be able to compare combustion and nuclear reactions, identify the reaction that produces radiant energy in stars, and to identify the forms of energy produced by the sun. These are your vocabulary words over here. Anytime you see one of those, you should highlight it. And these are your directions. I'll let you pause the video and read those directions. Now, before we can talk about how the sun makes its energy, we have to talk about bonds. A little bit of background information. We have to talk about bonds. There's lots of different types of bonds. We're going to talk about nuclear bonds and bonds between atoms. When you form a bond, it stores energy. When you break that bond, it releases energy. If it takes a lot of energy to form the bond, it's going to release a lot of energy when it breaks. So in nuclear bonds, you have very, very strong bonds, and they're hard to break. So they're going to store and release a lot of energy. Whereas bonds between atoms, they're weak bonds. They don't really store that much energy, and they're easy to break. They don't store that much energy. They're not going to release that much energy when the bonds break. So that leads us to combustion. Combustion is a reaction where you break and reform bonds between atoms, specifically a hydrocarbon most of the time. And here you're going to store and release energy. So let's look at that a little bit closer. This is the reaction for combustion. And this is a hydrocarbon. You know it's a hydrocarbon because it's got a carbon right here and a hydrogen. So here's your carbon right here. And you've got 1, 2, 3, 4 hydrogens. See, one carbon, 4 hydrogens, 1, 2, 3, 4. So this is called methane. This is a gas. This one's a gas. Methane gas is swamp gas, so you could burn that. You could also burn, this combustion is a burning reaction. You could also burn peat moss, coal, propane, wood. Any of those things have a carbon or several carbons in them and hydrogens. So we're just going to say hydrocarbons. So if you have a hydrocarbon and you burn it in the presence of oxygen, oxygen is a diatomic element. So here's an oxygen, here's an oxygen. Di means 2, so it's diatomic. You won't have to know that for the test at all, but if I give you the word, you should be able to figure out what it means. 2 atoms. So you're going to take your hydrocarbon, you're going to burn it in the presence of oxygen, and it's going to break the bonds. It's going to break these bonds. Right here. Break that bond. Break that bond. Break this bond. Break this bond. When it breaks the bond, it releases energy. That energy is released in the form of heat. And sometimes radiant energy, but mostly it's heat. And it also produces carbon dioxide. Carbon dioxide is CO2. I think you all are familiar with that. You've all seen that before. So it's going to produce carbon dioxide, and here's what carbon dioxide looks like. CO2, right there. And water vapor. So again, this is a gas. This is a gas-like. This is a gas, and this is a gas. But if we're talking about trees or coal, that's a solid. So it doesn't have to be a gas. I'm just saying. So again, combustion has a hydrocarbon and an oxygen that's broken down to release heat and carbon dioxide and water. So a combustion reaction is one type of reaction that stores and releases energy. Another type is nuclear reactions. Nuclear reactions are putting together or breaking apart nuclear bonds. Remember, those nuclear bonds are really, really strong bonds. So they're going to hold a lot of energy and release a lot of energy. Whereas with combustion, we had weak bonds there. That's your bonds between atoms. So those weak bonds are going to store a little bit or release a little bit of energy when the bonds are stored, released, formed, broken. So with nuclear reactions, we're talking about a whole lot more energy. There's 2 types of nuclear reactions. There's fission and fusion. That's what we're going to talk about now. So fission means splitting. And if you think about it, here's an S and an S. And if you have scissors, it splits. So if you're going to cut paper, it splits the paper. So here, fission is splitting the nucleus of an atom. Now, nuke means center. And if nuke means center, we're talking about the center of the atom. So here is a uranium-235 atom. You won't have to know that. I'm just telling you how the basic process works. So here's your uranium-235 atom, and you're going to have neutrons that bombard this uranium, and as it bombards it, it breaks it apart, releasing, here's a nuclear product, here's a nuclear product, and some neutrons that are kind of left over. But mostly the big important thing is the energy. Right here, you got a bunch of energy that's produced from that breaking down of the uranium nucleus. So this is what you get in nuclear power plants. In the sun, produces a lot of energy there by splitting the atom, specifically the nucleus in the atom. So if that's fission, fusion would be the opposite of that. Fusion means you fuse two things together. If you fuse them together, you bring them together and combine them. So with fusion, let's say we have two hydrogens and one helium, and that energy is stored. When it comes together, it releases a bunch of energy. Not stored, released. So let me explain to you what hydrogen and helium are, and that'll make a little bit more sense. Get a new board. Okay, so here is our periodic table. And before we get started talking about fusion, you need to understand what hydrogen and helium look like chemically. So here's hydrogen right here, and here's helium right here. So with that in mind, I'm going to now show you in detail what they look like. And you've probably never seen what I'm getting ready to show you before. And that's okay. It's not going to be on your test. You just need to understand this concept. It makes it a lot easier if you can understand this concept. So hydrogen, as we just saw right here, hydrogen has a mass of 1 and it has a number of 1. So when you're making what the structure looks like of an atom, you have protons in the nucleus and neutrons in the nucleus. So your protons are equal to your number, so that's 1, and your neutrons are equal to these two numbers subtracted, so that's 0. So hydrogen has 0 neutrons in the nucleus. Here's our energy level on the outside, and it has 1, because its number is 1, it has 1 electron. Now if we take 2 of those, so it has a mass of 1 and a number of 1. Here's its atoms. I wonder if you could draw these on your own, if I wasn't doing it with you. Here's the nucleus. So we've got 1 proton and 1 neutron. Oh, did you catch my mistake? Does it have 1 neutron? No, it's got 0 neutrons. And N0 is the abbreviation for neutron, because it has no charge. P positive is the abbreviation for protons, because it has a positive charge. And here's your electron on the outside. There's just 1 of them. There we go. Now helium, let me make the color different for helium. Okay, so helium looks like this. It has a mass of 4 and a number of 2. Here's its nucleus. Oh, that's way too big. Here's its nucleus. Its nucleus has 2 protons. Subtract these 2 right here and you get 2 neutrons. If you take its energy levels, it's only got 1 energy level, but it's got 2 electrons. Look, 1 electron plus 1 electron equals hydrogen, helium. Dang it, helium. So if you fuse these 2 together, if you fuse 2 hydrogens together, you're going to get helium. And that's also going to produce a lot of energy, a whole lot of energy. So energy in fusion. And fusion means to fuse 2 things together. And here we fuse 2 hydrogens together. Okay, so going back to our notes. Fusion, like I say, is when you fuse 2 of these hydrogens together to make helium. And this is what the sun uses to make its energy. And you can see in the diagram that I have right here that you have something called deuterium. That's just a different form of hydrogen. So here's a hydrogen, and they fuse together, and they produce a lot of energy. So that's all that diagram means. What's produced from that fusion and all that energy is electromagnetic waves. And we're actually going to do that next on our next video. So you can stop this one here, and anything you didn't get, you can go back and make sure that you understand it. You can play it again. There are 3 review questions, and those review questions within your paper that you have, you should stop right there. It's a little red circle with a question mark in it. You should stop there and make sure that you answer those questions correctly. I'll be checking those.